This is an application of ordinary differential equation to resisted motion, which is an application of Newton's second law of motion, F equal to m times a, where F is the external force acting on the object and a is the acceleration of a moving object. Let's look at the following example. An object of mass 1.5 kg is released from rest at the top of a metal slide inclined at 30 degrees to the horizontal plane. Let's picture the diagram. You have an inclined plane, inclined at 30 degrees. The object, the mass, sliding down from the inclined plane. The mass is 1.5 kg. The direction of motion is downward along the plane. Now, the air resistance is numerically equal to half the velocity. So that means there is air resistance opposite the direction of motion, and this air resistance is equal to half times the velocity. At the same time, the coefficient of friction is 1/4. That means there is a friction oppose the motion. Coefficient of friction is 1/4. So what we want to find out is what is the velocity of the object 2 seconds after it is released. So we know in the beginning the object is released from rest. That means when t equals 0, velocity is equal to 0. So what we want to know is when t equals 2, what is the velocity? To start analyzing the problem, write down the equation of motion, which is F equal to ma, or ma equal to F, where a is the acceleration. Since we are trying to figure out the velocity at time t equal to 2, so we replace a by dv dt. So when you solve this equation, you'll be able to answer what is the velocity at time t equal to 2. Next, we are trying to figure out what is the total force on the object. To find out the total force, you must not forget the gravity. This is why the object slides down. So there's an mg here. However, not all the mg are responsible for this downward motion because the object is sliding down along the plane. So you dissolve this mg into two components. One is perpendicular to the plane, one is parallel to the plane. Now from here we know this angle is 30 degrees. Using a right angle triangle or similar triangle, then the force that is responsible for this downward motion is this component, which is mg sine 30 degrees. So the downward force is mg sine 30 degrees. But they are also resistance, which opposite the direction of motion, so you minus the resistance, which is one of them is air resistance, and also you minus the friction on the plane. which we are going to examine one at a time. Let's look at the air resistance. The question tells us that the air resistance is half times the velocity. So this portion here is half V. That means half the total force F on the object is mg sine 30 degree minus half V minus the friction on the plane. Let's try to focus on friction on the plane. Now, friction on the plane is equal to the coefficient of friction times the normal force. So what is the normal force? In this case, we have mg here. The normal force is a force perpendicular to the plane, which means this component is n, where the angle is 30 degrees. So from the calculation, this n is equal to mg cosine 30 degrees. Therefore, the friction is 1/4 times mg cosine 30 degrees. Putting down the value of m, which is 1.5, g is 9.8 meter per second square. Cosine 30 degrees is equal to 3/2. And we find that this is 3.1826 Newton. Therefore, the total force on the object is m times g, which is 1.5 times 9.8 times sine 30, which is 0.5, minus 0.5 times v minus 3.1826. Now, 1.5 times 9.8 times 0.5 is 7.35. So the total force is 7.35 minus 0.5 V minus 3.1826, which is 4.1674 minus 0.5 V. To summarize, we have m times a equal to f, where a is dv dt, and the f is 4.1674 minus 0.5 V. Now m is 1.5, so we have 1.5 times dv dt 4.1674 minus 0.5 V. Divide both sides by 1.5. I have 4.1674 over 1.5 is 2.7782 minus 0.5 over 1.5 is 1/3. This will be the equation of motion. And that finishes part 1 of this example.